Okay, we are looking at IP14. This is problem 19. So we are applying our properties of exponents to kind of a lot of pieces, right? We've got a fraction bar here, which means we got a division problem separating up this monomial here on top, or that chunk of multiplication down the bottom, that monomial. The way I like to approach these is when I have an exponent all the way on the outside, I kind of like to deal with that guy first. So what I'm going to do is I'm going to take every single piece in here, right, because they're all connected with multiplication. Every single piece in there is going to get raised to the fourth. So I'm going to set up a fraction bar, and I'm going to do 2 to the fourth power. Then I'm going to take my x squared and I'm going to raise that to the fourth power. And the rule for taking a power, right, and raising it to another exponent is that we multiply those exponents. So this is going to become x to the negative 8. Then I have y to the third. It's raised to the fourth. So again, I want to multiply those exponents. So I'm going to get y to the 12th. I'm going to do the same thing here with each piece on the bottom. 3 to the fourth, x to the fourth, and then y to the negative 4 raised to the fourth, so negative 4 times 4, y to the negative 16. All right, so I have a few things here that I need to deal with. One, this needs to be worked out. 2 to the fourth is going to be an actual number. 3 to the fourth is going to be an actual number. And now I have some negative exponents that I need to move. But to me, what jumps out before I even deal with those negative exponents is, look, I have multiple x powers. One is in the top, one is in the bottom. So I want to apply my rules for dividing powers of the same base to the powers with an x as a base, and then the powers with a y as a base. So I can kind of do a lot of those things sort of at once. I'll get my fraction bar set up here. 2 to the fourth power, 2 times 2 times 2 times 2. That's 16. If you want to use a calculator, you can. 3 to the fourth power, that's 3 times 3 times 3 times 3. Here, I'll show you that in the calculator for this one. 3 times 3 times 3 times 3. 81. So that's going to become an 81. And now I'm going to divide these. Now this is really important. When I'm dividing powers of the same base, I need to subtract top to bottom. So the signs are going to hold as to what they are. So this is really x, and then it is negative 8 minus 4. You can see I'm subtracting top to bottom. This y is 12, and then it's minus a negative 16. So that does become a little bit weird. You got to keep track of all those negatives and the subtraction. So let's see here, what am I going to get? I'm going to get 16 over 81, and then I'm feeling a little bit lazy. I'm going to do negative 8 minus 4, and I'll just do that right in the calculator. Negative 8 minus 4. If you're doing it in your head, though, it's fine. It's negative 12. So that's x to the negative 12. I'm going to have an exponent here on y. That's 12 minus a minus 16. It's effectively 12 plus 16, but you can do 12 minus a minus 16 right in the calculator. You're going to get 28 either way. So now the last thing that I kind of got to deal with here is I got this negative exponent. All of my exponents should be positive by the time I finish this problem. So this whole thing has got to move. Negative powers means it needs to move. This is effectively dividing by 12, or by x, 12 times in a row. So I got 16 over 81. These can't be simplified. This only has factors of 2. This only has factors of 3. No common factors. Y to the 28th will stay up top because of the positive exponent. X now to the 12th because now I'm dividing by an x basically 12 times in a row. And that is where I end up. This is my final answer. Hopefully that's helpful. Message me anytime with questions.